Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is Eric Thune. He's from a company called Velocity Compute. Eric, welcome to the show today.
Thanks, Rich. Looking forward to it.
So, Eric, we're hearing more and more about HPC in the cloud, and it seems like one of the bottlenecks or barriers has been getting the data there, getting the data out. Is that what you guys are centered around?
I think that's one of our key value propositions. I kind of call it the dirty secret of hybrid cloud, which is, how do I get my data to the cloud quickly, and more importantly, how do I decide what of my monster amount of data on-prem do I move to the cloud? Now, all the cloud vendors obviously would love you to move all your data up there. The problem with that is it kind of negates the whole point of cloud bursting, which is, how do I act quickly to take advantage of compute in the cloud?
Well, Eric, I'll tell you what, I've brought up your slides. Why don't we go through that, and then we'll do a Q&A at the end.
Okay. And we're going to talk about some of the challenges people are seeing. And, although we mentioned the cloud, what PeerCache and what Velocity Compute does is actually solve the problem or many of the problems on-prem as well as moving to the cloud. So let's talk a little bit about the challenges. First, I think it's no surprise that people see NAS performance degrades at scale. The more people that I put on a NAS device, the bandwidth continues to drop, and when it's being hit by a number of applications at the same time, we see very, very poor performance. So one of the solutions to that has been to go to all-flash storage. All-flash, as everybody knows, is just very, very expensive. If you look at the HPC workflows, we see a lot of copies being made all over the place, and these workflow copies are very difficult to dedupe, so that just ends up in very inefficient use of storage and many, many unnecessary copies of data all over the place. So now let's get to the challenges in the cloud, and this is really going to be what our focus of the presentation is today, but we've got a ton of legacy applications that are, let's call it, challenging to run in the cloud, and in some cases almost impossible to run in the cloud because they were never written to run in the cloud. They call data from all over the place, and no one really even knows what all that data is necessary to run in the cloud. And as I mentioned earlier, the whole data transport latency negates the whole benefit of cloud bursting. So if I want to quickly today say I want to use 1,000 machines on Amazon or AWS, how do I quickly move the data and decide what data to move up to the cloud to be able to do that? So Velocity Compute is really about accelerating your data. And when we say accelerating your data, we're talking about on-prem, hybrid cloud, and also being able to give you performance at cloud scale. So one of the key things about our product is that we decouple the application performance from the storage in the network. You want to be able to get the best performance necessary, and you don't want it to be dependent on a specific cloud's storage infrastructure to be able to get performance. We give you, and this is really one of our key value propositions, is we give you seamless cloud bursting. And what that means is we can take any application, run it on any cloud with zero provisioning, running it on bare metal, essentially, and have that come up and run in minutes. And we'll show you an example of that in later in the presentation. Another key benefit here is that it's a software-only solution. There's no big dollar hardware outlay. You don't have to buy, these all-flash storage systems to be able to get performance. There's no need for a new file system. So we're not changing the paradigm in how you do things. It's really just kind of comes up and runs. And another key benefit is that the whole process here is on demand. If you look at a number of the other let's call it performance file systems that operate in the cloud, they require you to have, literally dozens of instances up and running 24 hours a day, 365 days a year to be able to get the performance that you needed. With our product, it really, you can spin it up and spin it down very quickly, so you're dramatically reducing both the cloud and storage costs. So we've talked about this a little bit, and I call it the hybrid cloud data transfer problem. But the problem is we have this elephant of data stored on premise. And moving it all up to the cloud is not only, going to take tremendous amount of time, but it's going to cost a tremendous amount of money to be able to keep that data up in the cloud. The question is, what's really needed to run my job? And that's where we show this little butterfly here on the right. It just says, this is, I really just need not even a fraction, it's a fraction of the data to be able to run my jobs. The key problem is, how do I decide what fraction of data is necessary and only transfer that amount of data? We also have what I call the public cloud lock-in problem. So, of course, cloud providers want customers to upload and store everything. We know that's going to be very expensive. But a big problem is every cloud provider has different storage infrastructures, which makes it very difficult to be able to utilize multiple clouds. We're typically going to code up some scripts or something like that based on the storage infrastructure, and either we have to redo that for every cloud, otherwise it's not going to be very portable. So all of this makes it difficult to leverage competing clouds for CPU costs. So once you're locked into a cloud, you have all your data up there, you have your scripts written for that cloud. It's very hard to negotiate with the cloud vendor to be able to get lower costs because they know you're locked in. And lastly, no one wants to keep data on-prem as well as up in the cloud. Paying for it twice is just very expensive and obviously just doesn't make sense. Lastly, compounding the whole problem is shared storage performance. Scaling in the cloud is very challenging. We also see that rewriting a lot of these legacy apps is difficult to impossible. For instance, we talk to people in the oil and gas industry, and some of their simulators were written 20, 25 years ago. So making that investment to rewrite them is challenging at best. People also have huge investments in their on-prem data centers, so they don't want to just throw those away. And lastly, we have multi-way synchronization issues. So if I'm going to move everything to the cloud, or I'm going to move a large portion of my data to the cloud, how do I make sure that it stays in sync with the data that I have on-prem? So our answer to this whole problem is called Velocity PeerCache, and I'll go through some of the key benefits. But the first one is we will automatically move the minimum data required in both directions with ultra-low latency. So what does that mean? It means that at runtime of the application, we'll dynamically determine what's needed not only for the application, but for the data of the application. We also do what's called file extents. So for instance, if a file is a gigabyte in size, but the application only pulls, let's say, a megabyte or two from that file, we'll only transfer the megabyte or two versus having to transfer the whole file. Now, a whole key to the architecture is that we use small amounts of NVMe as ephemeral caches. And when I say small, we're actually talking in the terabytes, but that is considered small these days. But these ephemeral caches cache these file extents that I was just talking about, and it acts as a least recently used cache, and it gives the application essentially near local performance for access to this data. As I mentioned earlier, it's 100% agnostic to any cloud application or data set. There's zero provisioning, and we're going to end up dramatically reducing the storage footprint with what we call copy invariance. Okay, so we're going to do a demo of PeerCache, and what we're going to demonstrate today is hybrid cloud bursting using PeerCache. Now, PeerCache can also be used on-premise or between different clouds, but today we'll focus on just hybrid cloud bursting. So the first thing that we're going to show is these two windows in black on the left-hand side are essentially on-premise. And what we're showing at the upper window is two directories on an on-prem file system. The window below that is just a command window of PeerCache, so we could kind of see what's going on in the background. What we'll be talking about is a technology we call the holodeck. And holodeck is an old Star Trek reference, but what we're really using it here for is to project an image of your on-prem file system into the cloud virtually instantly. So let me start the demo here, and the first thing we're going to do is on the right here we've got a bare metal instance in Amazon, and we will do a DF so that we can show that that's bare metal, and then we will start the holodeck. You will be able to see those directories from on-prem directly on the instance in the cloud. And after that, we'll start a HPC application, and we'll show you how that all works. So I'm going to start right here. We're going to just do a quick DF. And you can see there's nothing on this instance now except for this NVMe, which is shown in the window just below it. Now we're starting up the holodeck, and we're essentially mapping those two directories that were in the upper left window. And now if we do another DF, you can see that those two directories show up almost instantly. We're going to do a quick ls on those directories, and we can see all of the contents of those directories, but we haven't transferred any data at all at this point. So now what I'm going to do is I'm going to change directories, and I'm going to start an HPC application that is called a Virtuoso. It's a CAD tool from Cadence Design Systems. A couple of important points here is that Virtuoso's install tree is about 20 gigabytes. And then the data associated with that is about another gigabyte as well. So all we do is now we're in the cloud instance, we change to the directory, and we start up the normal script that we would on-prem to run Virtuoso, and let's see what starts happening here. Now you can see some files actually being transferred in the window on the left, and if we look at the NVMe window, which is the ephemeral cache, we're starting to fill up that cache or that NVMe with all the files necessary to run the application. You can note that it's significantly less than the entire install tree, and we never really did an install at all. So quickly pause this here for a second and explain what's going on. We have only transferred 322 megabytes out of the 20 gigabyte install tree. We also did not install anything into the cloud instance at all. Everything has just been transferred into this NVMe cache. Now we're going to turn around and start loading the database for this CAD tool in, which I mentioned was another gigabyte of data. So we'll start doing that. We're going to pick that out and start doing the load, and you're going to instantly see that we're starting to copy some more data as well up to the cloud. And we're going to get up to, I think, approximately 375 megabytes out of a total of 21 gigabytes that would have normally had to been copied up into the cloud. So I think you can see it's 374 megabytes right here. The tool is up and running. And here's one of the really cool things about this. We can just shut down this instance of the application running. But because the cache is already hot, the tool is going to come up much, much faster than it did before. So it took about a minute to load before, And now you'll see that the application runs in about 10 seconds because everything is running out of the NVMe, which is, got very low latency to the instance running. And now we're going to load up the database as well, which again was another gigabyte of data. And you can see the whole thing comes up really rapidly. So again, this is just a demonstration of us doing cloud bursting. You could do this on-prem by adding small amounts of NVMe, and what we're able to do is essentially break the bottleneck of your filer and your network and be able to give you much higher performance for all your applications.
Okay, so one of the big challenges we see is I/O scale out. And we've got the issue of scale out versus scale up. Scale up is obviously very expensive. We see that NFS shared storage is struggling to provide the I/O scalability necessary for HPC applications. Central filer metadata presents a significant bottleneck. So if everybody is going back to the filer for stats, they get overwhelmed. And we see customers having to purchase large capacity to be able to mitigate these performance issues. Another challenge is that sequential I/O turns to random I/O with heavy utilization. So PeerCache provides scale out for all file workloads, and the important aspect of this is that again this works on-prem as well as in the cloud, as well as cloud bursting. So what we're doing here is breaking the dependency on the storage system and the network to provide performance by using this local flash as cache. And that was, kind of shown in the demo before. So PeerCache can be looked at as a software-based file system accelerator. The I/O performance is at local NVMe speeds, which is, today at 2 gigabytes a second, moving faster, and it aggregates with every node. So with every node I add in the cloud to, or even on-prem to do that, I now aggregate this I/O. So if I have five nodes, I can provide 10 gigabytes of I/O. All these file extents are cached based on the application demand. And then we also provide a peer-to-peer networking, which can deliver high-performance reads and writes to these local ephemeral caches. The caches are much more cost-effective than all-flash arrays or fabrics. It provides fully POSIX compliance with NFS semantics. So we can accelerate your on-prem, we can accelerate your all-cloud-based application, or we can accelerate, obviously, anything that you want to cloud burst. I know we've kind of given a very high-level overview. If you would like to learn more, please feel free to contact me at this contact information.
Well, great, Eric. Thanks for sharing that. A couple questions come to mind. Now, you showed Cadence, which is an EDA application. What other disciplines or application spaces would benefit from this cache approach?
So we're seeing actually applicability in a number of different spaces. Oil and gas, for one. We're seeing rendering for animation studios, also biogenomics. Really, almost any high-performance compute application that utilizes a lot of data as well is a good fit for what we're doing.
Okay. And you're a software-based solution, but do I need that NVMe storage array on my side to make this work?
So great question. If you're utilizing the cloud, there's many instances available in the cloud that have the NVMe attached to them already. So it's maybe a slightly more expensive cost per minute or hour to use that type of instance. If you want to do this on-prem, you do need to add, like I said, small amounts of NVMe, which is really very inexpensive to
your compute instances.
Yeah. And what major cloud providers are you looking at this working with? Is it going to be the usual suspects, AWS, Google Cloud, and Azure?
Yes, as well as private clouds.
Terrific, terrific. Well, Eric, I guess we've got a lot of listeners out there. I'm wondering if their ears are perked up about this. How do they kick the tires on this and see if it works for them?
Well, as I said, you can contact me. We'd be happy to do an evaluation. I think we can show people that in the whole cloud bursting scenario, how we can really take any application and have it running in literally a matter of minutes. So I think it's easy for us to prove it to customers, and we're happy to do that.
Wow. Well, Eric, this is very exciting. I know we've been talking for a while here. You've been kind of in stealth mode. Is this generally available now?
We do have a couple of customers in production. We will kind of be launching the company soon, and until then, we're keeping kind of a little quiet about what we're doing, but we wanted to give your customers a flavor and hopefully see if there's some interest. We'd love to engage with them.
Yeah, because those HPC folks are trying to be on the edge of everything, and cloud is certainly a big movement as we discussed. So Eric, I really want to thank you for coming on the show today.
Thanks a lot, Rich. We're looking forward to talking more.
Okay. All right, folks, that's it for the Rich Report. Stay tuned for more news and information on high performance computing.